Okay, today we're going to continue looking at solving rational equations. You may remember that a rational equation is any equation that has a fraction part to it that may contain a variable in the denominator or even the numerator of that fraction. And what we're going to look at today is how to solve that, how to set it up so that we can solve it as a normal equation, that we don't have to really worry about the fractions there at all. The first thing you're going to want to do is identify the least common denominator of all the terms in the equation. Once you find that, you're going to multiply that least common denominator to everything there, every term in the equation, whether it's a fraction or not, every single item. Once you do that, you'll simplify all of your expressions out, and your denominators should all cancel at that point, leaving you with no denominators, no fractions in the problem. Now what you'll do once you get that is you'll have an equation there left over, and you should be able to solve that using either quadratic techniques or just like a linear equation. We'll solve it however we might need to. And then we'll get our answer and we'll check it. We're going to take the value that we find for x or whatever we're solving for, plug it back in, and make sure that none of the denominators in our fractions become zero. And if that happens, we're going to have to rule out the answer that we get in that case. So we would take whatever answers were left over. All right, let's jump in and look at a couple of examples. Our first example asks us to solve this equation. And the first thing we're going to want to do is look at the denominators. We only have two of them, x minus 8 on both of these. Excuse me, let me check this out. All right, we got x minus 8 on both of them. So we should be able to easily identify, even though this one does not have a denominator, we should be able to identify what the least common denominator is. And of course that would be x minus 8. So we're going to take that x minus 8 and we're going to multiply it into every term in the equation. So let's look at how that happens. We start off, we have 1 over x minus 8 minus 1. And that's equal to 7 over x minus 8. Excuse me. You'll notice I'm leaving a little space here, and you'll see why in a second. We're going to take that x minus 8 and multiply it through to all of the terms. As I do that, let me fix that up a little bit too. As I do that, we're going to basically multiply it into the numerators. So we multiply x minus 8, x minus 8, and x minus 8. Now following the rules of multiplication, we would just multiply it into the numerators every time we did that. So this is what we get. Now you'll notice that we can now simplify some of these terms. X minus 8's cancel out here in this first fraction. Nothing cancels here, so we'll just have to go with that. But we also get these x minus 8's to cancel out in the final fraction as well. So we're left with an equation now that has no denominators, which is good for us because we don't like to work with the fractions. It's a little bit easier to go without them. So what we're left with from this first term is 1 minus what we get when we take this negative 1 and distribute. That should give us minus x and plus 8. And then over here, we're left with just 7. Now that's just a simple linear equation that we can be able to solve fairly simply. The first thing we would do would be collect like terms. Over here on the left side we have negative x plus 9, and that's going to be equal to 7. The next step then would be to subtract 9 from both sides. So we'll say minus 9 and minus 9. That gives me negative x is equal to negative 2. And then of course we would divide by negative 1 on both of these, and we would get a final answer of x is equal to 2. Now you're going to want to take that and plug it in up at the initial equation up here and make sure that that does not make any denominators equal to 0. So if we take 2 here, that would be 2 minus 8 on both of these. And of course that would give me negative 6 on both fractions. So -6 is not 0. So this answer is okay. It's a good good answer. So our final answer is that x is equal to 2 here. And then in a nutshell, that's the process that we go through every time. We identify our least common denominator. We multiply it to all of the numerators or all of the numbers in every term of the fraction, or excuse me, every term of the equation. And then we get an equation to work with, and we just solve our equation by the ways that we've learned, the techniques that we've learned throughout this course. Let's look at another example, a little bit more complicated maybe. Here we can see we have a few different, or a couple of different denominators here to work with. Let's look at, first off, factoring out this denominator here. The x minus 2's are fine, but we can factor out x squared minus 7x plus 10 by finding the factors of 10 that will add to make -7. And hopefully by this point you're catching on that that would be x minus 5 and x minus 2. So our least common denominator includes all of the factors that we have, and that would be x minus 2, and then of course x minus 5 with that. So we've identified our least common denominator. We're going to take that and multiply it in to all of the fractions there. So let's write this out. I've got 1 over x minus 2. I'm going to add that to 1 over, we got x minus 5, x minus 2 there. And then that's going to be equal to 6 over x minus 2. So as we multiply that through, we're going to see that some things happen here. We're going to multiply x minus 5, or excuse me, x minus 2, x minus 5. Again, that's our least common denominator. X minus 2, x minus 5, x minus 2, x minus 5. Once we do this, you can see that parts are going to cancel out. We have x minus 2's in this fraction are going to cancel out, so you're left with 1 times x minus 5. In this second fraction, the x minus 5's cancel out and the x minus 2's cancel out, leaving just 1 behind. In this last fraction, the x minus 2's cancel out, and it leaves us with 6 times x minus 5. So we have some parts to our equation now that make it a little bit easier to work with. So we have 1 times x minus 5 plus 1 that we get from that second fraction equals 6 times x minus 5. And that's really nice for us to work with. We should be able to solve this equation fairly simply. We'll start off by distributing. So that would be, we distribute 1, I didn't even mean to do that. That gives us x minus 5 is equal to, we get over here and we get 6x minus 30. So we would collect like terms. That's x minus 4 is equal to 6x minus 30. Our next step then would be to subtract x from both sides. And I'm running out of space here, so let's move it up. That leaves -4 equals 5x minus 30. We'll then add 30 to both sides. And I realize I'm showing a lot of steps here. Hopefully you understand everything going on at this point. We divide by 5, and we get x is equal to 26/5. If you're having a problem with that, you can write it as a decimal. It would be 5.2. So either of those answers is fine. We would then go back up to the top, double check. Can we plug in 5.2 into this? That would be 5.2 minus 5 and 5.2 minus 2. Neither of those would come out to be 0. So I think that this would actually work. We don't have any extraneous solutions here, so your answer is x is equal to 26/5, or 5.2, however you like to word it. again, we went through the same process. We identified our least common denominator, x minus 2, x minus 5, and we took that least common denominator and multiplied it through every numerator in the problem. And that, of course, gave us an equation to solve, and we worked it out pretty easily. Okay, our next example is very much along the same lines. I'm just going to give you a few problems here I wanted you to kind of review with me on. We look at our fractions and our denominators. These first two don't factor at all. This last one factors to 3 times x minus 2. Well, you can now look at this. You have a factor of x minus 2 and a factor of 3, and then 3 and x minus 2 in the last fraction. So we can identify our least common denominator as being 3 x minus 2. So we will multiply that through to all of the fractions or all of the terms in this equation. And we'll just kind of go back through that same process. X over x minus 2 plus x over 3, and that's equal to 4x over 3 times x minus 2. So we're going to multiply that 3 times x minus 2 to everything. It's going to look a little weird here, but I've got that. I've got it here, and I've got it here. Now, a lot of times we'll start, we have a tendency to want to start jumping in and just multiplying everything out. Not really what you want to do here. You want to go ahead and simplify first. In fact, if you go back to the steps that we looked at the beginning, it said multiply the LCD to every term and then simplify to get rid of the denominators, to get the denominators to cancel out. That's what you want to do first. You don't want to jump in and start multiplying here, because if you want to get those denominators to cancel out, you're going to need to keep them as they are in factored form. So we'll look at this, and we can see that the x minus 2's are going to cancel out in our first fraction. In the second fraction, 3 cancels out with this 3. In the third fraction, 3 and x minus 2 cancel out, so it leaves just behind the 4x. So our equation is now going to take form into 3x plus, when we distribute here, we'll get x squared minus 2x, and then over here we've got 4x. So now we're just going to go through the process of cleaning this up and then solving the equation. As we move the screen down a little bit, we have x squared, 3x and minus 2x will make plus x is equal to 4x. And of course your rule is when you have an x on both sides of the equal sign, you get rid of one of them. We'll get rid of 4x here. And this is kind of a neat one. It's going to give us x squared plus, or excuse me, x squared minus 3x equals 0. Well, x squared minus 3x can be factored, and that's what we'll do. We're going to look to factor this. It's a quadratic. We're going to get 2 answers here. If we take a quick look at this, it factors out by taking an x out as a GCF. They both have x on them, so we'll take that x out, and that leaves us with x to the first minus 3. And that is the factored out form. Now we have 2 factors, x and x minus 3. To solve this, we get the values that would make either factor equal to 0. Well, this x would turn to 0 if x was equal to 0. This x minus 3 would turn to 0 if x was equal to 3. So we get our solutions, x is equal to 0 or 3. We should go back and double check. If x is 0 or 3, is it going to make any of these equal to 0 on the bottom of the fraction? Well, I think it works in all cases that both of these answers would work. So our answers come out to be good. So our 2 answers for this problem are x is equal to 0 or 3. All right, last example here for the day. We've got a nice trinomial here on the bottom of our first fraction. So let's take that apart and factor it down. The factors of 6 that will add to be 5 would be, make this x plus 2 and x plus 3. Well, that's nice because it goes along with these as well. These don't factor, of course. So our least common denominator is going to be x plus 2, x plus 3. And we're going to take that, and hopefully you're getting pretty comfortable with the process at this point. Our next step would be to take this and multiply it into all of the fractions in the problem, or all of the terms in the problem. So we'll go back to what we had to begin with. We'll factor that, x plus 2, x plus 3. So there's our first fraction. Our second fraction is x over x plus 3. Our last fraction is 4 over x plus 2. So we're going to take all of these fractions, and we're going to multiply our least common denominator into them. So we've got x plus 2, x plus 3, x plus 2, x plus 3. And you should be able to see some things are going to cancel out. Hopefully you're picking that up and you're knowing what to expect here. As we see this, the x plus 2's cancel out, the x plus 3's cancel out in that first fraction, and that leaves us with just 3x. In the second fraction, x plus 3's cancel out, and that leaves us with x times x plus 2. Well, that's going to become, real quickly, x squared plus 2x. Okay? Over here, in the last fraction, x plus 2's cancel out, and that leaves us with 4 times x plus 3. So that should become 4x plus 12. And putting some things together here, adjusting everything to where we need it to be, you can see that this is a quadratic because we have the x squared, so we'll put that first. Plus 2x and plus 3x, or positive 3x, will make plus 5x. Over here, we still have the 4x plus 12. We're going to subtract those things over. I'll do them both at the same time, just to save a little time for you. Minus 4x and minus 12 all together. That gives us x squared. 5x minus 4x is positive x, and then minus 12, leaving 0 on the other side. So we have a quadratic formula, or a quadratic equation, in the form of a trinomial. You can either use the quadratic formula, which would work nicely in this case, or we could just go ahead and factor this. If you recognize the factors of negative 12 that we'll subtract to make a positive 1 in the middle, you might be able to factor this pretty quickly. Those factors would be x plus 4 and x minus 3. And of course that means that x would be equal to negative 4, which we get from this, the value that would make that factor equal to 0, or the factor that would make this equal to 0 would be positive 3. So we get negative 4 or 3 as our two solutions. We'll slide back up to the top, see if that works. Does negative 4 work in both of these? That would be that would be negative 2, and this would be negative 1. So that would work. Was it 3 or negative 3? It's 3, so we're okay. 3 in this case would make 6 and 5, so we don't get any zeros in our denominators. So these two answers, I know I'm sliding all over the place here. These two answers are good. Negative 4 and 3 are the solutions to this equation. Okay, hopefully you've got a little bit better grasp of solving rational equations. Hopefully you can take this information along with the problems that you've been given and get some work done and master this skill. If you have any questions, please be sure to speak with me in class or outside of class, and be preparing for that test that's coming up soon. Have a good day.